So this page goes back to when we were talking about slope and how there are special cases of slope when it's horizontal or vertical. This kind of goes back into the Hoy-Bucks thing we were talking about, so I'm going to write that back. Okay, so remember Hoy was horizontal lines, that was zero slope, and y equals. Bucks was vertical lines, undefined slope, and x equals. Josh, do you have any sense? So when you're given these graphs, or these equations, and you have to graph them, remember which one is which, and you'll be okay. So for number 7, they gave us a y equals. So since it's a y equals, this has to be a zero slope that's horizontal. So I'm going to start at y equals -5, and then just graph it looks really small. Just try your best. Find when y equals -5.
I have pencil sharpening lessons after school. Why?
So find where y equals -5 on your y-axis, and then draw a horizontal line at that point. For number 8, this is an x equals, so this is going to be a vertical line that has an undefined slope. On your x-axis, find where x is -1. You can put a point there, and then you're going to draw a vertical line through that point. Mine was kind of over here, so that's okay. So when you have x equals some number or y equals some number, and that's it, it will be a straight horizontal or vertical line. Questions on how we did that? Yes, Kaylee. Undefined slope, so. Okay, the next minute, and yet, you don't think now, let's see, 30 seconds, 2, 9, 10. So 9 and 10 should look something like that. So 9, where x is 3, should be a vertical line when x is 3. And 10 should be a horizontal line where x is 8. You kind of know that you went the wrong way. Like if I put this horizontally at 3, x wouldn't just be 3, it would be all of these values. So that wouldn't really help us. Same thing with 10. If I flip this and made it a vertical line, y would be all of these questions related to those, but also slope. So if I just ask you, what is the slope of the line y equals 5? What would that be? Use the void box. Would be undefined for y equals. Zero. Would be 0. So if I ask, what is the slope of x equals negative 2, what would that one be?
Undefined.
That one would be undefined. I'm just going to put U and E. Now the third one, or the last one, is kind of a trick question. But if I said, what's the slope of x equals 0? It's still undefined. We'll put in that 0 to throw you off, but it's still an x equals, so it's still undefined. I'm going to draw in these two graphs, and then we're going to talk about what is different between the two. Just in case you don't remember, on the right, start at your y-intercept, and then go up 3, right 1, up 3, right 1, as many times as possible, and then go back to your y-intercept and go down 3, left 1, down 3, left 1, as many times as possible. I just realized my motions are the opposite of what anyway. What are the differences between these two? Okay. So one has a 0 slope, one has a number that's not 0. So I wouldn't say that one doesn't have a slope, because it does, it's just 0.
Guys, if you forget, like let's just say, I don't remember, put y is 3 up here. If it means it's always 3, well, it's always 3. That means y is over here. It's over here. Y is 3. It's how far you go up. It's over here. That's all you know. So the x value doesn't. You just know y is 3. So just I can go straight up in the x-axis. So that helps me remember it's a straight line. You know x is 0. All that tells you, you just know you're not going anywhere. You just know you're going either way. You're not going either way. And yet you're just going 0. You just x is always 0. So I would plot a few points. If you forget, I don't remember y equals that up. Just plot some points. Just say y is 3, y is 3 there, y is 3 there, y is 3, wherever. Just x is 0. Doesn't move off the y-axis. You go right or left, negative or positive. You just 0 everywhere. So I just plot a few points. If you forget, maybe if you remember, you can see it in your head, fine. But if you forget, just plot some points.
Okay. What are some other differences between these two graphs? We know that one was like a numerical slope, one was 0. Okay, so one's strictly horizontal, one's diagonal. And
Oh, no, I thought you were talking about y.
well, the difference between both. So I could say one is a positive, one's a negative, so that would kind of go back to what he said, but in a different way. Yeah. Any other differences you see? What about the intercepts? are there differences between the intercepts? So they both have X and Y intercepts? No. This one only has a Y intercept. It does not have an X intercept at all. This one has both. The ones that have X and Y will always have both. The ones that have Y or just X will only have one. I think those are all things.
Are these two slopes equal? Is this 3/1x? Is that slope equal to 3x? Is that the same thing? Yes or no?
Yeah.
No.
How?
You say yes originally, didn't
Yes.
you? This is just, remember, slope is rise over run. When this says 3x, all you're seeing the y value. You always got to think that this is a fraction. It's up 3/1. Same thing. Yeah. So just see, again, write it as a fraction so you see the rise and the run. You need to do that. Those are the same. So,
This last part is graphing by intercepts. So when you see this, it'll look very similar to the graphs that were in standard form. These will be in standard form. But we're not converting this back to slope intercept form. We're just finding the X and Y intercepts and graphing it like that. So when you see this on the test, it won't say graph it by X intercepts or convert it. It'll just say graph the line. So if it's given in this form, and we wanted to do it by X and Y intercepts, it's kind of like how we were solving X and Y intercepts. So this is cover up the Y term, solve for X, cover up the X term, solve for Y. So the cover up is like putting 0 in for one of the variables, solving for the other part. So in this case, you're going to have your X and Y intercept as points, and you're going to draw a line using just those points, not your slope and Y intercept like we have been doing. So for number 1, I would pretend the Y term is there for X, set the X term equal to -6. Yes. And solve for X. And then I would plot that point, on my graph. So X is -2 would be this one right here. And then I would go back and I would do the same thing for my Y term, pretend the X term isn't there, or like I put in 0, and then so I got this -2y equals -6.
You said our test on Friday?
No.
Our quiz on Friday? You have anything on Friday?
Use the name.
Oh, no, this is first.
Yeah, that's supposed to say center.
Oh. Yeah, the quiz.
So solve for Y, get that Y intercept, plot that point. You need 2 points to make a line, so once you have those 2 points, connect them. And now we graph this by intercepts. Could I go back and now find my slope because I can find the slope by counting from any 2 points? Sure. Do I need to do that for this? So this is strictly finding the X and Y intercepts, graphing them from that one second. Not converting it and finding the slope and Y intercept. You can do one or the other. I would not do both. That's your question.
What is everything you need for the Y and the X? Because 3 is X. 3 is X.
3 is the number. Not X. 3 is not X. numbers in front of it doesn't automatically mean that's what it's going to be. This method only works if both numbers in front of x and y are factors of whatever c is, whatever that last number is. If this said 3x minus 2y equals 5, neither of those are factors. This will be one where you have to convert it. So if you're wondering, how can I tell, that would be like your go-to. So if you can solve it using x and y intercepts and you like that method, you would do it that way. If you would rather go back and convert it, you can do it that way. Just don't do both. And then some of them can only be converted and you can't do the x and intercepts. We're going to do one more of these. So for number 3, both of these do not have numbers in front, but numbers with 1. So if I were to set the x term equal to 3, nothing for me to solve. I would just plot the point at x equals 3. Same thing for my y value. And I would grab those 2 points. Or connect the line with those 2 points. So if it specifically says graph using x-intercepts, then do that. Do you have any questions on graphing by intercepts?
Yeah.
So you have the rest of this page and then there's 4 on the back. If you finish those within this time frame, you can move on to the practice at the end. I think there's some. So I'm going to give you the next 10-ish minutes. Work through as many as you can. We'll go over whatever answers you need. And then we'll start our next set of notes. Ask any questions you have, if you have any. X-intercept is positive 5, y-intercept equals 3. So when I connect these 2, it makes this negative 1. Any others we want to check?
No, because I marked you present. Oh, she was already. Okay, never mind. I'm good. Did I give you these already? I feel like I did. Can you ask Garrett if he wants those? Can you ask Garrett if he wants those?
I'm sure.
Alright, so the first part of this is finding the slope, finding the y-intercept,
putting those two together in our equation. So, identify the slope, identify and y-intercept. Right and intercept, or slope. So, I think the first couple actually have, actually have a slot for M and B, and then the rest don't. But if that still helps you to see what they are before putting them in the equation, you can write it off to the side. So some of these I think have points, but the lines are a little weird, so you might have to look for it. I would say try and find your lines at first because that's easiest to spot wherever it crosses the y-axis, but I can't really see it up there. -3? Yeah. And then find 2 points on the graph. So this one, I can start with the y-intercept. There is another point drawn on there, right there. But you also could have chosen this point right here because it goes through the background grid lines exactly. So as long as you find 2 points that cross the grid lines exactly, it's fine. And then count your slope up and over. Always go up or down first, and then right or left. What would that slope be? 3/1 or just 3, so always simplify. And then that equation would be y equals 3x. Let's get that one. So again, if it helps, off to the side you can write what M and what B are. If you would rather not do that and just write the equation, that's fine too. Y-intercept is really easy to spot. On the y-axis is +1. Slope here, I see this point was drawn in, but I could have also done this point. What would that slope be? +3? Yeah. So in this case, if I'm starting here and I go down 3 and right 1, is that still a positive? No, it's negative. So this should be a -3 x plus 2. Remember, if you go down or left in only one of those, you're going to end up with a negative. But if you go down and left, that's negative over a negative, so that's positive. I'm going to skip to the next page. A lot of these are we're going to skip to 13 and 14, and then I'm going to practice the writing it from a graph. So 13 gives us the equation we are looking for, but it's multiple choice. If you wanted to eliminate some, get rid of the ones that don't have a y-intercept at -2. So this one, this one. Which of these would be our equation? Because it has that slope up 1.3. The other one I think has a slope of 3. Right. Now for the other one, we're given the graph, and we have to find which equation is right. To eliminate, well, these all have y-intercept and negative ones, so that doesn't help. But I see this is going down and right or up and left, so it has to be a negative slope, so I can get rid of A and B.
this one be C or D? And you could go back and double check. It has a line intercept behind one. I see points all throughout this. So you can count any 2 points. And I'm going down to and right one or up to and right one to get that slope to -2. Slopes with whole numbers are also steeper than slopes with fractions. Questions on either of those? I'm going to give you the next 5 to 10 minutes. It may not take that long to go back and try all of these examples that we didn't do. So 2, 3, 5, 6, and 12. And then we'll come back and talk about those. Do you have the time to work? You just look like
I think you're okay. It's probably you and not me.
So for the first page, you have y equals -3 x plus 2. If yours doesn't match mine, before you erase it, say something because I just did these really fast. I'm also looking at the board really closely, so it could be wrong.
No, number 3. I thought that was never mind. Ignore me.
3, 2/5 x plus 2. 4, -3x plus 1. 5, 3/2 x plus 3. 6, -2/3 x minus 2. Yes.
I don't know. I think I got it nice and tight. So first you do for the M. First you do the y-intercept and then you do the x-intercept.
I would say finding the y-intercept is easier for me, but you could easily find the slope first. We're not finding the x.
No, like after you find the slope-intercept, to find the slope.
Y-intercept.
So find this one,
E,
the
the
y-intercept.
y-intercept.
Okay. And then after you find this, to
The M.
find the M.
So you're not using the y-intercept. You don't have to use the y-intercept to find the slope, but it is easier if you start at the y-intercept, yes.
Okay. So to do that, would you do y? Would you do on y or x?
You always go up or down before you go left or right.
So y. Like, hey.
Second page, and we did it in the
Wait, can you go back to 5 and start reading that check?
You're looking for 2 numbers. One you can see, the other one you do have to do a little calculation.
So if you miss a 7, x minus 3, if you put 1x minus 3, that's fine, but you don't need that one. 8, 2x plus 4, 9, negative x plus 1, but if you put negative 1x plus 1, that's fine too. 10, 1 half x minus 4. 11, y equals negative x, or negative x plus 0, or negative 1x, or negative 1x plus 0. And 12, negative 2, there's x plus 1. Leah, what was it?
How did you get 1 from the 7?
So in this case, we put up 4 and right 4.
Oh, it's the highlight for it. Okay.
Questions on any of those? What did you say? Anyone still need? I'll come back to these ones. So the last part that we're talking about, and I don't think I said this earlier, is writing equations when given a graph. So we were graphing equations when given the equation. Now we're doing the opposite. So this part is the easier part of the writing, where you have to find your slope, find your y-intercept. So I would say the hardest part about this is making sure that you don't switch your slope and y-intercept / making sure your slope is going in the right direction. It's positive. Go on to the next page. We'll come back to any questions. So just like when we were graphing these, we were given some x equals a number, y equals some number, and we had to graph that line. Well, now we're given the graph and we have to write the equation. So remember your guts. I'm not going to write it out again. But horizontal, 0 slope, y equals. Vertical, undefined slope, x equals. So if we have a vertical line, look where that x, it's going to be at x equals, look where that x crosses the x-axis, and that would be your equation. For these type only. If you have a horizontal line, look at where this will cross the y-axis. I'm sorry, the where it will cross the y-axis. This is going to be a y equals, so this will be y equals negative 1. We'll do 2 more together, then I'll give you the next 2 others. Would number 1 be an x equals or a y equals?
X.
X equals, and what does x equal? So then 2 would be a y equals, and what does y equal? Again, if you need to, you can find the point where it crosses the x or the y-axis. Okay, for the next 30 to 45 seconds, do the other 4. Number 3, what was y?
Negative 5.
4, what was x? So this is actually on the y-axis. And then number 6 equals y. Questions on those? So if you remember Hoylux, all of these questions for writing graphing slope becomes 10 times easier. If you don't, then you have to remember it some other way. These are very much like what we did before when we were graphing. It was just kind of placed in the wrong list, but that's okay. So we're not really going to do a lot of this unless needed, but I'm going to fill out this top part. So slope intercept form, y equals mx plus b. You need to know that. Where m is the slope, b is the y-intercept. Again, things we need to know. Standard form is not necessarily something you need to remember, but you need to be able to recognize it. On the left side of this, it's always ax plus by for the standard. So on this side, it's giving you the slope and y-intercept and asking you to write the equation of the line. So kind of what we were doing with the graphs, but it gives it to you. Do we need to see any of those? And then the right side is what we were doing last class when we were graphing, the last part of graphing, converting it into slope intercept form to get that y-intercept, to get the slope intercept form. Do we need to see any of those? So it is there. You have additional practice. Make sure you are good with those things. They can go on to the last page. Last page, I think there's practice at the end. I don't know if we'll have time to get through all of this, but we'll do the top part and then we'll see. So the next portion of writing equations is when you're given a slope and given a random point. Somewhere on top of this, I think you have extra space. Write this down. Y minus y1 equals m times x minus x1 in parentheses. This is called the point slope formula. And we use this when we're given a point and a slope. So for this, I would label everything just so you know what is what. So the point would be your x1, y1. Slope is m. So those three things you're going to put into the formula and start solving. And it will look something like this. So the y and the x in here are going to stay y and x. So y minus y1 is 1 equals, our m is 3. And then x minus x1 is 2. That's part of the question. Negative what? We're always subtracting. So if we're just taking that
right from the point. Think about slope, because slope is always starting. Once you have it in this form, you are going to distribute the 3. You get 3x minus 6. And then to get it back in slope intercept form, get this 1 away from it by adding it to the other side. So we end up with the equation y equals 3x minus 5. And that would be our equation of the line, or our equation in slope intercept form. Do you have any questions on that process? Process itself is not hard, it's just remembering what to do. Let's jump to number 3, because that one has a negative, and I want to show you what happens when we have those negatives. Leave it as a fraction. It would be 1/2. So for number 3, same thing, label these, x1, y1, and m. And then put those 3 things into your point slope form formula. Y minus, here my 7 is negative, but I was subtracting, so I want to put both so I know this is what's happening. Equals -1 times x minus 4. Here you could do this one of 2 ways. You can distribute it and then make the negative and then the minus and the -7 become a plus, or you can do those at the same time. So I'm going to do them at the same time. This would become y plus 7. This would become -x plus 4. And then I'm going to move 7 over by subtracting. So y equals -x minus 3. The negative and the minus came together to make a plus. It's like 2 negatives always make a positive. Same. If you happen to have 2 negatives, so your x and y are both negatives, that means they would both become a plus on the inside. So I would do this inside and do that part first before you distribute, because that'll change everything. I don't have an example like that up here, but you could easily make an example where I have like -1 and -1 and integrate the slope and then do that. The last one I want to do with you is number 6, because you end up doing your fractions.
Are you trying to get the y by itself or the x by itself? You're doing a linear equation.
So with this one, same thing. Put these all in. We have y minus 4 equals -3/4 times x minus 6. Distribute. So you could this over 1, saying negative 6 times negative 3 times negative 6 is positive 18. 4 over 1 is 4. 18 over 4, you could simplify that to become 9 halves. If you had your calculator out, but if you did, I could also do that here, so I could say negative 3, fractions, if you couldn't go to alpha by equals, it'll give you the fraction bar. Put in 3/4, multiply it by negative 6. It will simplify it for you if it's in fraction form. If you don't put it in fraction form, it's going to give it to you in decimal form. And then add 4 to both sides. So doing that algebraically, you would have to get common denominators and add them together. So this would be 8 over 2. We have negative 3/4 x plus 17 halves. But if you had your calculator, you could also put that into that. And you'd get the same thing. So y equals negative 3/4 x plus 17 over 2, or 17 halves, would be that final answer. Until about 2, I want you to try those 3. It may not take you the whole 15 minutes to do those 3, but work through those. If you know how to do those or remember to do those, you can move on. But we'll do those next.